Hello everyone, welcome back to another video on my YouTube channel. Today we'll be discussing another problem from the Blind 75 list of problems, and this problem is named container with most water. In this problem we are given multiple lines of varying heights in an array, and we are supposed to find the max area bounded by two lines in this array. For example, the heights of these lines are 1, 8, 6, 2, and here the max water that two lines can contain between themselves is between these two lines, which is this thing which I have shaded here. And what will be that area? So to calculate that area, we have to calculate minimum of these two. So for example, minimum of this is 8 and this is 7. So I'll just write down how we calculate the area. So minimum of height I and height j. Once I found the minimum, I have to find the width, which will be the distance between them. So that will be simply j minus I. So this is the area formula that we'll use to calculate area between any two lines. Now the most straightforward approach to solve this problem can be to calculate area for each pairs and find the max of those. So in that case, there will be how many pairs? NC2 pairs, which is n into n minus 1 by 2. So what would be the time complexity in that case? It would be O of n square, as we are calculating all pairs. And space complexity would be O of 1. But will this solution work? We are given that n is 10 raised to power 5. So n square solution won't work in this case. Now what other solution can we think of? Let's consider a two-pointer solution where we have two pointers L and R, and L points to the first number initially and R points to the last. Then what we do is that we calculate the area between L and R. So once we have that area, so for example, initially L is here and R is here. So we calculate this area, which is bounded by L and R. Now once we have this area, we can either move L to the right side or R to the left side. And we know that area is bounded by dependent on two things, which is width and height. And we know that we have to either do L plus plus or R minus minus to get the next two pairs. And both of these would result in reducing width by 1. But what about height? What is limiting our height here? So for example, when we calculate this particular area, which of these two lines are limiting us to getting more area? Is this L or R? Yes, it is L. Because if we don't move L, we'll keep getting these areas, these areas, these areas, and width will also keep reducing by 1. But if we choose right and move L to the rightwards, then area increases and we get this area. Similarly, now R is the limiting factor here because R is smaller than L now. This is L and this is R now. So we move R leftwards. Then we get this height. Then again move R leftwards and then we get this height. All these heights will compare against each other and we find max of those heights, which will give us the answer. If you still didn't get this, I'll leave a link of an article which will help you understand the solution very easily and also the proof for it. So we know that height is limiting, and if height of L is less than height of R, then we'll do L plus plus. Otherwise, if height of L is greater than height of R, that means we'll do R minus minus. And if both are same, what can we do? In that case, we'll just do both. Now, what would be the time complexity here? As we are only moving these 2 pointers left and right, that means we are iterating the array once. So in that case, time complexity would be O of n, and space complexity would be O of 1. Because we are not using any extra space to solve this, only the input array. Now let's see how we'll write code for this solution. Here I am given a function max area with the input vector of type int called height. Now what I'll do is create a result variable called max area and equate it to 0. Similarly, create the left and right pointers, initialize them, and then start the loop. And what did we discuss we'll do? First, let's calculate the result. So max area is equal to max of max area and current area. And let's quickly calculate the current area as well. So current area will be, what did we discuss? Minimum of left height and right height multiplied by the width, which will be R minus L. Then we store the max area, and then we have to move the left and right pointers. So for that, we compare the heights at L and R positions and move these accordingly. So here we'll do R minus minus. And if both of these are not true, then we just move both the pointers. And at the end of it, just return the max area which we calculated. Now let's try running it. Okay, both the test cases worked. Now let's try submitting. So as you can see, our O of n 2-pointer solution worked as expected.